So before I introduce myself, I was reminded to remind you guys that you can get scanned or you can scan actually a QR code later to win a prize. And if you let yourself scan, then you will get the slides in exchange after the call, right? That's well done. Okay, that's it. I'm done. Bye. No, just kidding. Okay, let me introduce myself. My name is David, and I would call myself a NoSQL geek and database guy. I worked over the years with relational database systems for a company called Ingress. Who knows Ingress? It's an indicator that you're old, by the way. Anyway, then some graph database stuff with a small graph database startup, which did something very similar to Neo4j, but in the .NET world. Then document database with Couchbase, and I think I work with Redis since about 8 years now, right? In different functions, or so doing some customer stuff. Right now, I'm responsible for clients and ecosystems engineering at Redis, which is the reason why I'm talking today about clients at caching, right? Good. Who of you knows Redis? Raise your hand if you know Redis. Oh, that's easy. So, who of you knows that Redis can do more than caching? Oh man. Okay. Anyway, so before I talk about caching, let me clarify that Redis is in general a data structure store and a memory data structure store. And as in a memory data structure store, it has a bunch of use cases. You can do queue management, you can do streaming, you can do time series data management even, but you can also use it for vector similarity search. So Redis nowadays is also a vector database. So if you didn't know, right? You might consider using it as such in the future. Who of you knows what a vector database is? I guess everyone, right? Ah, kind of. Okay. So basically, a vector is more or less a mathematical vector that you can embed in the database into a vector space, and then you can kind of do vector similarity search, right? By kind of looking for vectors around it. So what you need typically is you need to have a machine learning model which embeds any of your data, pictures, whatever, right? By calculating your vector, you store the vector in a vector database, and then in the next step, you basically search for vectors that are similar to that vector, whereby the similarity is kind of expressed as the distance within the vector space, right? Simple, I would say, right? So, and you can use this, for instance, for doing retrieval augmented generation or for doing semantic caching and so on. But that's not the topic. So meaning let's talk about our clients at caching in a second, right? Clients and ecosystems engineering. So part of the introduction is that I'm part of the clients and ecosystems engineering team. And what we do is basically develop client libraries for Redis. So for you guys, for instance, Redis Pi, right? Who of you knows Redis Pi? Some of you. I guess most of you use Redis just as part of their normal frameworks, right? Like in Flask caching or whatever. But if you would use Redis Greenfield in Python, then you would use a library like Redis Pi, let's say, right? And that library is developed by my team. And in addition, by the way, also flood, right? So hey, and then in addition, we are responsible for ecosystem integration work, right? So by ensuring that the frameworks you're using are working nicely with Redis, let's say. Okay, Redis is a cache, right? So I guess I can skip here a bit through by not telling you too much what a cache is, but right. I think most of you know that you use a cache in order to speed up the access, right? So instead of you accessing your relational database system or another primary system, what you would do is you would access it from a cache, maybe from memory in case of Redis, and this basically gives you quicker response times. The main reason why we see that people use caches is that the main systems, like your relational database system, for instance, might have some scalability limitations, right? So it's not that easy to scale it horizontally, but it's easier to scale a cache horizontally. So you put a cache next to it, right, by kind of mitigating your issue, your scalability issue, right? Good. Some caching basics. There are some general patterns in caching, right? So one is write through. Write through means you kind of write first to the cache, And after you wrote to the cache, you would basically kind of synchronously write down to the primary system, right? And you would preferably read from the cache. Depends. Sometimes the data in the cache is invalidated, and then you would still read it from the primary system. Then write behind is very similar to write through, just that the write operation happens asynchronously behind the scenes. And then there's read through, so you kind of read always through the cache, let's say, right? By basically ensuring that all the data that you access is in the cache. So that's just for your information, right? Actually, if you want to implement those patterns with Redis, you need to do this by yourself. Most of the times, Redis is used with those two patterns here, right? There is locusite. So if you use Redis as a cache right now, then you typically use locusite, right? You double check, is the data in the cache? If there's a cache miss, you would basically go to the primary system, fetch it from there, and then put it into the cache. And the next time you would like to access it, you access it from the cache, right? That's the locusite pattern. And then there's another pattern that you can use with Redis data integration, which is a dedicated product, which is called CDC. Who of you knows CDC, Change Data Capture? Few. It's quite common. So what you do is basically you write to your primary system, and then you have kind of a transformation pipeline set up that in real time takes the data from your primary system and transforms it into the right format for your cache, and then you read it from there, right? For speeding up some of the accesses. Okay. Now, what is actually important for caching in general is the accuracy of the cache, right? So it's always a bit of trade-off. So performance versus accuracy in a case, or you could also say performance versus consistency in this context, because let's assume you put data into a cache and you always access it from the cache and never invalidate it in the cache, right? Then you can always access it fast, but you have always outdated data. It's also not actually what you would like to do, right? Instead, you have to kind of use mechanisms to make sure that your data is from time to time refreshed. And one of the mechanisms to use there is expiration. So Redis has a feature that allows you to set a key. In Redis, everything is a key value pair, whereby the value can have a specific data structure. You can set a key with an expiration, so which means after a specific period of time, the data deletes itself and then causes that you need to refetch it from the primary system, right? Kind of makes sense. Another kind of mechanism is eviction. So as soon as your cache gets full, you need to kind of decide how to basically evict data, right? How to get space for other data which might be more relevant, right, in your cache, and therefore you would use an eviction policy. Very common ones are least recently used and least frequently used. Recently used is more time-based, right? So the one that was basic data that was not that or not accessed for a long period of time is going to be evicted. Data which was recently accessed is staying, right? And LFU means basically data that was very often accessed is basically kind of staying in the cache, and data that's not that often accessed is evicted, right? Good. So far, so good, right? I think we understood caching basics now, right? But why do we want to use client-side caching then, right? Client-side caching kind of is a way to cache data very close to your client application, right? So Redis, most of you know Redis is a server solution, right? You have the remote dictionary server where you kind of cache your data. And in order to access this remote dictionary server, you have the challenge that you need to have network round trip, right? And this network round trip can actually kind of kill your performance to a degree, right? I mean, it's very minimal in some cases. It depends on your network environment, right? But it's visible if you do it millions of operations per second, for instance, right? So, meaning sometimes there are reasons why you would like to avoid this network latency for performance and scalability. A good example is, let's assume you have a hotkey in Redis, right? Hotkey is something which is accessed very often by you, right? And maybe because you access this key very, very often, right? So in proportion more often than other keys, let's say, right? There's a scalability impact because normally in a distributed system, you would kind of try to balance the accesses out somehow for performance reasons and scalability reasons, right? Now, you could avoid hotkeys by breaking them up to multiple keys and stuff like that. Sometimes there are use cases where you can't do this, right? And client-side caching could potentially help with that, because now your application has a copy of this hotkey, right? Your application instance, or in its own cache, right? And the other application instance has a copy in its own cache and so on, right? So each application instance accesses basically this key first from its cache by making the cached key and the actual cache, right, less hot. Does it make sense? Good. I have a little demo here. I hope I have enough time, right? It's only 2 minutes, so let's see. Okay. A little bit about the demo, right? Because I can answer some questions about this later. But the demo is constructed in a way that I have a sequential access pattern. So I basically just kind of create keys sequentially and access them sequentially, right? So no random access for the sake of this demo. Now, I just use 10,000 keys, or I only have a capacity of the local cache, the client-side cache of 1,000 elements, so 10%, right, is on the client side. And the payload is not that big. And as a network, I, by intention, use the network, which gives me some limitations. So so reality is we just had Easter, right? I visited my mother-in-law, and I was sitting in her office room with very shitty internet connectivity, right? And I had to kind of connect this demo. However, right, I think it kind of makes a point about the fact that the worse your latency in the network is, the more beneficial can be something like client-side caching, right? So bear with me a bit, especially about the total performance numbers. Redis is usually able to do something like hundreds of thousands, millions of operations per second, right? Even if you don't need it, maybe sometimes. But the demo kind of shows you. Let me kind of increase this a bit. Okay, so again, sequential workload pattern, one write for 2 reads. We are connecting to Redis with a bunch of connections, one for write, one for uncached, one for cached. And now we are basically running the uncached workload. And what you can see here is Redis Cloud, so the Redis Cloud UI, and the monitoring metrics being visualized there, what's happening. It usually has a bit of delay, right? It refreshes every few seconds or whatever. But I think the story comes through anyway. So what you can easily see here is, here in this case, with this bad network, I kind of pushed through something like 600 reads per second and 300 writes, because one write operation, 2 read operations, right? And I don't use client-side caching right now. And you can see it took, not yet, maybe in a second you can see that the traffic should drop. Then I wait 20 seconds, and I wait by intention 20 seconds there, to make it more visual on the UI that we changed some setting. So now you can see how long it roughly took to complete this workload, right? So the sequential writes of those 10,000 keys with 2 reads per key. And then, again, 20 seconds. Maybe I should have prepared something like a singing act or whatever, right? To just fill those 20 seconds. But okay, fine. Now we start the cached workload, right? And we're done, right? Because now most of the reads, or half of the reads, were basically kind of cached. And what you can easily see here is that we had half of the, or let's say half of the reads that we had before, right? And because we used basically the client-side caching here, right? We actually kind of increased our writes by the same amount. Hope this makes sense. Okay. So how does it work, right? So Redis has a feature, and this feature is called client tracking, right? So client tracking is basically, and we remember I spoke about accuracy of a cache and invalidation, and that this is a problem that you can solve via TTL. But here in this case, this client-side cache, so the cache that is living within the application, basically, right, is kept up to date automatically by Redis. So whenever you change a key on the server side, Redis is sending a push notification to this client connection by telling this client connection, hey, your key is invalid, let's say, right? And then the client can basically delete this key from the cache by making sure that the cache is more accurate, let's say, right? The way how this works is you need to kind of send a command on the same connection to the server, which is like, hey, let's enable client tracking. Optionally, you can redirect the invalidation messages from that connection to another connection. That's most importantly necessary if you use RESP2, because RESP2, it's the Redis serialization protocol, doesn't support push notifications, but only pops up on dedicated connections. But this is a technical detail that's not that relevant. Let's say, then you can filter, you can broadcast to all of the client connections, or you can kind of opt in. Or by default, you would basically need to opt out, right? But you can also say, hey, I would like to make sure that before I kind of cache anything, or I need to send this client caching, yes. Okay. So where does it live in the client library? So that's more or less the architecture of Redis Pi. So if you look at this, Redis Pi, and usually people think that client libraries are easy, right? And they are. Redis Pi is actually one of the more simple ones, I would say, right? There are others like he's saying no. But if you compare it with something like Lattice, I'm not sure how many of you are Java guys. Lattice being an asynchronous client library, right? Doing some reactive stuff and using Netty and stuff like this. It's much more complex, right? Behind the scenes. But in general, you basically have the actual connection, keeping a TLS or keeping a socket connection being TLS encrypted. Then you have some abstraction, serialization, deserialization. Then your client library needs to be able to discover the topology changes on the server side. So basically, if you have a cluster, you would like to find out if a node kind of moves and would like to inform the client, so the client can proactively reconnect and so on, right? There's a lot of stuff that what a client library actually does. And what it does in addition is, for instance, client-side caching, right? Or also sometimes token-based authentication. Good. So how we implemented it in Redis Pi is more or less like a second layer of look-aside, right? So what we do is we basically say, okay, fine. We read on miss of the remote cache from the primary system, let's say, right? And then we basically kind of put it into the application, put it into Redis as your main cache, right? The next time we would read from the main cache, let's say, so level 1, let's say, right? Or depends how you define this. You would basically retrieve it from Redis and put it into your local cache, right? Because the next time you would like to basically read it from the local cache, right? And then as soon as you read it from your local cache, right, you read it from your local cache until someone changes the data again in Redis, right? So Redis being used as your main cache maybe. And this kind of pushes an invalidation message up to the application or to the client library precisely. And this client library then is basically saying, okay, fine, because I got an invalidation message, I'm removing this from my local cache, basically, right? Make sense so far? Okay. So it's kind of two layers of look-aside, if you want so, right? So we kept it a bit simple in the first iteration. So client-side caching in general has more functionality than we have in Redis Pi right now. The first design is only on RESP, or the design that we did for the client-side caching functionality in Redis Pi only uses RESP 3, so only push notifications, no redirects or whatever, right? We have a default cache implementation, which is just based on ordered dictionaries, right? We only support a number of elements because sometimes it's hard to kind of, let's say, predict the actual memory consumption, right? Especially if you have languages that are kind of running in a script runtime or whatever. So we said, okay, fine. Instead of kind of limiting it by memory consumption, we limit it by number of items. We use least recently used and the cache key. So the key within the application cache is the command that was executed plus the Redis keys that were kind of involved in this command. And then we share a cache per group of connections. So one connection pool basically has one cache, right? So instead of duplicating the cache or across connections of a pool, we basically share one. Kind of makes sense. And the cache is enabled. So there's a whitelist, which you could theoretically override, but right now the whitelist is on all read commands that you can do, right? So whenever you execute as a read command, search command, or whatever, you will basically kind of cache the data in the local cache, right? Code example, how can you use this? If you want to use it, make sure you have RESP 3, so basically the Redis protocol 3 enabled, because this comes with, let's say, this push notification support, and then pass a cache configuration. The cache configuration is very simple right now. I mean, theoretically, you could implement your own eviction policy or whatever, but the one that we ship is basically the default, and the default is LRU, which leaves it to the maximum size. Here in this case, I played around with 10,000, right? And then that's it, basically, right? That's the only thing you need to do. You need to instantiate a cache config, basically pass it over to the Redis connection, and then you will basically cache some of the data locally in your client, right? Okay, maybe call to action from my side is if you want to test it by yourself, right? Then you can open a free cloud account and use Redis Pi 5.1.1 or higher, right? Which basically brings this as a feature. And then if you want to test in Redis Cloud, you can also test it with Redis 7.4 or higher on your local machine if you want. But if you want to test it with Redis Cloud, ensure that you have a database that has this API version, right? 7.4 is the minimum version, yeah. Okay. A little bit about what's happening in the ecosystem beyond client-side caching. So again, the library we are working on is called Redis Pi, right? And Redis Pi recently got token-based authentication. Is right now in beta. So if you want to authenticate to Redis, specifically Redis Enterprise in this case, right, or Azure Cache for Redis or Azure Managed Redis, you can use token-based authentication with Azure Entra ID. Then we have new commands in Redis. Who of you knows hash field expiration? Never heard about it? Oh, one. Okay, good. So I spoke about this kind of expiration of keys and so on before, right, in the caching basics. Sometimes if hash field expiration, I think, makes sense for this as well, but hash field expiration allows you to not expire the entire key, right? So not the entire key has a time to live, but a property within a hash, right? A dictionary that you store in Redis has a time to live, basically, right? Which is in particular useful if you do session management, right? And you would like to kind of have a session that is more or less to a degree persistent, but it gets invalidated by, for instance, expiring a token within the session, right? Something like that. Then we have hybrid vector search. Who of you uses a vector database right now? I also already asked. So I'm not sure if I can tell you what you use, so I kind of don't do it. But in principle, if you want to combine basically vector search with some other queries, like hey, please give me everything of this category that is close by or whatever, then this is called a hybrid vector search, and we have a library that's called the Redis vector library, and Redis VL is basically the one that's used for vector search, and it supports hybrid queries since a while, and it supports it even better now. Then there is a new service that we launched, which is as a kind of preview, I would say, right? Which is semantic caching as a service, right? That's maybe interesting for you guys. Semantic caching is not just caching; it's caching plus a vector database. So, or in a sense, what you do is you would like in a cache, you fetch the data always by the exact key, right? In a semantic cache, you fetch the data from the cache based on the semantic context, right? So meaning you need to have the vector database first in order to find something which is similar, semantically similar, and as soon as you found it, you can basically fetch the element from the cache, for instance, to save some tokens, right? So if you use an LLM and you don't want to pay too much for tokens, and you know you have already some of the data cached, right? Some of the answers cached. You can kind of have similar questions and play out basically the cache data then based on the semantic meaning instead of. And you can use Redis VL and Redis directly for this, but we also have a new service that basically provides this already out of the box, right? Okay. And there is a SDK coming up for this. And then vector stuff as well. There's a new data structure in Redis that's called vector sets, which allows you to use Redis as a vector database. There are right now two ways to use Redis as a vector database. You can either use our query engine, or you can use the vector set as a data structure. If you want to use vector sets as a data structure, you can also try it out with Redis Pi right now. And now I am informed that it's only 1 minute. So any questions?
Thank you so much, David. I've got a couple of questions in
okay,
Slido.
cool.
But before that, even though I work with Redis day to day, it's always good to refresh the memory, especially with the different types of caching techniques.
Refresh your cache.
Refreshing the caching, yeah. And also, it was really brilliant that you used a video demo, because demos can always go sideways when you do them live. Okay, then I've got a couple of questions.
That's the reason, not because I'm shy to do live demos.
Yeah. So the first question. So what's the? Oh, it looks like a controversial question. So what's the advantage of using Redis over Walkey? Can you elaborate on the open source controversy that happened?
Yeah, Walkey is not as good as Redis. That's it. No, I mean it's a complicated question, right? So most of you might have heard that Redis changed its license. The license change was something which we did because yeah, hyperscalers, cloud vendors are using open source software to provide services, right? And Redis was one of the last that actually changed the licenses and the license change only has one implication: you can't provide it as a service, right? And maybe I leave all the other details to your imagination, let's say, right? So you can still use it freely, right? You can still kind of take what we provide. You can take the source code. You can do whatever you want, right? However, you can't provide Redis as a service with our new license, let's say, right? And by the way, that's the same for other vendors as well. Let it be Mongo, let it be Confluent, let it be whatever.
Okay, not sure. Looking at the time, if we can manage, I've got like 5 more questions, so I'll be quick. So does client-side caching work with asynchronous implementation in Redis Pi?
Sorry?
Does client-side caching work with async implementation in Redis Pi?
Not yet. We are working on it. There's a second iteration planned, but we prioritize the synchronous API first because we believe that, but people here might correct us, we believe that Redis Pi is more often used with the synchronous API than with the asynchronous one, right?
Yeah, thank you. So the next one, does the Redis Pi client has any C dependency? And if you can tell if it's compatible with PyScript, Python interpreter compiled to
it has
WASP.
an optional dependency to a C library called Redis, which we use for response parsing. So if you want to speed up response parsing, then you can plug in Redis, but it checks if this is there as a dependency. I think there's a wrapper Python library or whatever, right? And if this is not installed as a dependency, then it will not pull it in. Otherwise, it will pull it in. So it's an optional thing for performance reasons. Besides of that, it's pure Python.
Okay. So how effective is client-side caching when using a serverless service?
if you use a serverless service, okay. I mean, client-side caching with serverless is as effective as if you use a server, basically, right? Because the application, your serverless, whatever, right? At the end, needs to use a cache to speed up some access, right? And this is not different than with others. Let's
Yeah.
say, right?
Thank you. Which semantic similarity metric are you using for lang cache, which is gonna coming soon?
Vector, which metric or which function?
Yeah, semantic similarity metric.
Semantic similarity metric.
Are you using for
Typically the similarity is given by the model that you are using, right? So the model is responsible for embedding it, and based on the embedding model, your accuracy is better or worse. And then there are some functions for finding similar elements like cosine similarity. I'm not sure if this answers the question, but yeah.
Okay. And the last question. So with the alternatives to Redis appearing after some licensing changes, will Redis Pi evolve into server agnostic library?
So Redis Pi is not planning to be Redis only, right? It can be used with any kind of RESP service, RESP server right now, including Valky or any other thing that is using RESP. However, Redis as a company provides end-to-end to support for their customers, right? And that's a reality, which means if the server solution diverges, right? And there are two communities now, right? Redis and Valky. So if the server functionality kind of diverges, there's a chance that the client libraries diverge as well, right? I mean, client libraries have a purpose. They have the purpose to make the functionality on the server side very accessible for you, right? And if the server product diverge, then there might be a chance that the client also diverges, right? I hope this answers the question.
Yes, right? It does. So thank you so much for those elaborative answers, and please give a round of applause to David.